11 done? No? Yeah. Okay. Right, okay, in the triangle, right here we have a triangle, obviously, right, 74 degrees, 15 centimeters, 22 centimeters, and they said find x to z. I'm just going to put an x on that, and then it also said find angle YXZ. So YXZ is at the middle one, so I call that capital Y. That's what I'm looking for. Is that right? Okay, so first thing find X, next thing find Y. So capital A, small a, capital B, small b, capital C, small c. So I'm going to get an X first. Okay, which rule? Which rule? Going, the three pieces of information I have are two sides and the included angle. That means it has to be what? The cosine rule. That's one of the conditions for the cosine rule. So it has to be the cosine rule. So the cosine rule is a squared equals b squared plus c squared minus 2bc cos a. So fill in a is x squared, is what I'm looking for. B squared is 15 squared plus 22 squared minus 2 times 15 times 22 times the cos of angle 74. Okay, so no rearranging because the x is over here that you're looking for. Into the calculator, press equals, get the square root of your answer, and that would be, this is, does anyone have an answer for me, just to, because it's just calculator work? 19.7. Number 11, 23 centimeters. Okay, is that all right that I just skipped to the answer there? Okay, are we good? Now the second part of number 11 says find angle B, right? Find angle B. So I have, this is 23 centimeters, okay? So my question is, can I use the sine rule? Because the sine rule is easier to use, right? Okay, so you have a full set, as in you have capital A, small a, and you have half a B, don't you? You've small b and you're looking for capital B. Would you agree? So you can use the sine rule, A over sine A equals B over sine B, okay? So A is 23, just figured it out. Sine A is sine of 74, right, equals B is 15 over sine B, which is sine of capital B, which is what you're looking for. Okay, right, sine rule, cross multiply, so you get 23 sine B equals 15 times sine of 74. Divide each side by 23 and you end up with sine B is equal to, turn that into a decimal, okay, so whatever it is decimal wise, okay, and then get the inverse sine, so then you have to go shift sine whatever that answer is up there. Okay, and equals, and round it up to the nearest whole number, and you get 39 degrees. Is that okay? Are we okay with that? So mixture, cosine rule, sine rule. Right, okay. That's number 11. I gave you number 13 was next. Anyone need me to do 13? Yeah, okay. So number 13 is, the diagram shows wires attached to a communications antenna. Right, okay, we really don't care. What we need is the triangles. So there we go. This is 25 meters. This one is 32 meters. They tell me this is 12 degrees. And they tell me this here is H, is it, from here to here? Is that it? Okay. Find the length H correct. They tell me that's the right angle. Find the length H correct to the nearest meter. Okay, right. So which triangle do you have three pieces of information in? Right? It's a small triangle, isn't it? See the triangle up here? I know that that's 12 degrees. I know that's 32. I know this is 25. And I'm looking for H. Yeah? Okay, so we're just working in the small triangle. There isn't a lot to this one. I thought you might have to use triangle as well, but you don't. Unless you have to get the height of the whole antenna, is it? We'll see what the answer is. Right, they're not very clear. Capital A, small a. Capital B, small b. Capital C, small c. Right, okay. So tell me, which rule? Which rule? Cosine rule, because you have the two sides and the included angles, so that's one of the conditions for the cosine rule. So a squared equals b squared plus c squared minus 2bc cos a. So a squared is what we're looking for. B squared is 25 squared plus 32 squared. 32 squared minus times 25 times 32 times cos of 12 degrees. And work all that out and you get A is equal to, has anyone got an answer there for me? 9 meters. Is that okay? The end. That's all that was. One triangle. Right, okay. Are we good with 13? Right, the next one was 14. Am I doing 14? Right, okay, 14. Right, in a given triangle, okay, so it tells me this is 60 meters. This is 150 degrees. I can't work on that triangle. Right, in the given triangle, BC is 60 and angle. Find the area. If the area of triangle, so the area of the triangle is 450, right? Okay, 450 meters squared. Find the length of AC, right? Length of AC, I'm going to call that X, right? And the perimeter of the triangle, that means I'll need to get Y then in order to get the perimeter of the triangle. Is that okay? So again, I was able to look at that triangle and say, there's only two pieces of information in there, so I can't work with it. So here's my third piece of information. They're telling me the area. Remember the area of a triangle, we did it before we did the sine rule. It's a half AB sine C. Right? Okay. So if I call that capital C, capital A, capital B, small b. So it's a half multiplied by A, which is 60, multiplied by B, which is x, multiplied by sine of 150. And I know the answer is going to be 450. Okay, so what we need to do is we need to, on our calculators, multiply a half by 60 by sine 150. Will someone do that for me, please? Half by 60 by sine 150. Answer? 15. So we have 15x, right? Is that okay? So I've multiplied the three numbers I know, a half, 60 and sine 150 and got 15. So that's 15x equals 450. So then you divide each side by 15 and you get x is 30. Is that okay? So that means this side here measures 30. Now I have to get the perimeter of the triangle, right? In order to get the perimeter of the triangle, remember the perimeter of a triangle is you add up the length of all three sides. So I need to get this, right? Okay, so I need to get y, don't I? So which rule will I use to get y? Sine rule or cosine rule? Looking at that triangle and the information I have in it. Which one? Cosine rule, because I have two sides and the included angle, right? Okay, but look, it's C I'm looking for, so I'll just have to adapt the one in the log tables. The one in the log tables is a squared equals b squared plus c squared minus 2bc cos a. Now, because I have call this C, I'm going to adapt that to c squared equals a squared plus b squared minus 2ab cos of c. So the angle, whatever's on that side, matches the angle and the other letters are in there. Is that okay? Right. So that means c squared is equal to 60 squared plus 30 squared minus 2 times a is 60, b is 30, and that would be cos of c, which is cos of 150. Right, into the calculator with that, press equals, again get the square root of it. Someone might tell me the answer. I could just look at the back of the book too, but this is number 14. 16, 30 makes 90. I think when you work all that out, you should get 87 meters. I think, right? Okay, then you have to get the perimeter of the shape. So the question asked me for the perimeter of the triangle, right, equals 30 plus 60 plus 87, it'll be 177 meters.
Excuse me, please remind the teachers to do attendance on the portal, and if you could do it straight away, I'd appreciate it. Thank you.
Right, okay, are we good? Right, are we alive? It's like, yeah, I'm the only one talking. You're all okay? Right, okay, right. 15, am I doing 15? No one's speaking, am I doing 15? I'll take that as a no. No? Right, okay, great. Right, okay, I'm going to move on, but we're going to come back and go through more of those. They'll keep coming up and coming up. Right, on your lead cert, on the trig question, right, okay, you are going to be doing a cosine rule and a sine rule, right, okay, because they come up every year. So make sure you can do them, right? So they ask you a sine rule and they ask you a cosine rule every year without fail. Okay, so they're going to ask you this year, right? They're not going to change things up now for you. Okay, so make sure you can do them. You'll see when we do the exam questions that they come up all the time. Right, the next section, girls, is a bit out there, right? Okay, it's a bit hard to get your head around it. They don't ask it much, so I'm going to do it, obviously, because it's on the course, okay, but I'm not going to put a lot of faith in it coming up, because a lot of the stuff you can do it on the calculator anyway, but you need to know about it, so I shall do it, okay? Okay, so I need to talk about something called the unit circle. Now, will you listen to me first, and I'll give you a chance to write it down in a minute, right? Okay, why do we need to learn this? Okay, because we're going to talk about angles that are greater than 90 degrees. Ratios of angles greater than 90 degrees. If you get out your calculator there for 1 minute, right, and I'm going to throw some stuff at you. Don't write it down though, because this isn't part of my notes. Okay, the title is, but the next thing I'm going to do is, right, get me cos of 70. Now, I'm not interested in the number, I just want to know, is it positive or negative? It's a positive number, right? Okay. Get me sine of 120. Again, I'm not interested in the number, just tell me, is it positive or negative? Positive. Get me tan of 120. Negative? Right, get me cos of 320. Positive or negative? Positive. Get me sine of 320. Negative? Right. Okay, right. So what we're going to do is, you can't tell what number, you need the calculator to figure out what the number is. Okay? But you can figure out whether the answer is going to be positive or negative using the unit circle. Okay? So the unit circle just tells you, right, whether it's going to be positive or negative. Okay? So in the unit circle, right, first off, what is the unit circle? Right, so here I have my grid. Right, this is 0, 0. Right, so a unit circle, girls, has a radius of 1. So this is the unit circle. So the unit circle has centre 0, 0. So the centre is on the origin. And it's got a radius of 1. Okay, a unit is 1. Is that right? So this point here would be 1, 0. Wouldn't it? What would this point be here? 1. So it's across 0, up 1. There's another radius here. What would this point be? -1, 0. What would this point be? 0, -1. Okay, so that's the unit circle. Okay, so what they figured out is the unit circle, well, I just cut to the chase. Any point on the unit circle is equal to the cos of, sorry, I'll go down here a bit, so it's equal to the cos of theta, comma, sine of theta. Okay, so, and theta is just a Greek letter, and it's the size of the angle that it makes with the positive x-axis. What I mean by the positive x-axis, girls, is this bit of is this line here. This is the positive x-axis here. Right, so that would be cos of theta, sine theta. So if that angle was 40, If you got cos of 40, sine of 40, that would be that point, right? If the point was over here, right, the point is cos theta, sine theta. So if you make an angle, join it to the origin, now the angle it makes with that red line is huge there, see it? So that's the angle. So if we imagine that was 120, this here would be, if you got cos of 120, and then you got sine of 120, that would be the coordinates of that point there, right? Okay, don't worry too much about it, right? Okay. Right, you know here, what's the angle here? If this point was here, the angle would be 0. Would you agree? Because it's on the red line, so it makes no angle with it. So the angle would be 0, wouldn't it? So what's cos of 0? Cos of 0? Cos of 0 is the first coordinate. 1. What's sine of 0? 0. Here, what angle does this point make with the positive x-axis? Makes a 90-degree angle, doesn't it? Okay, from here to here, 90 degrees. Okay, so what's cos of 90? 0. What's sine of 90? 1. What angle does this one make if I go all the way back to the red line? What angle is that? 180. What's cos of 180? Minus 1. What's sine of 180? 0. Right? Okay. Down here, what angle would this make if I go all the way back to the red line? It would be 270. Very good. What's cos of 270? What's sine of 270? Minus 1. Right? And finally, this could be 360 or it could be 0. What's cos of 360? What's sine of 360? 0. Right, you can do it on the calculator anyway, but you're supposed to know about this unit circle. Is that all right? Okay. The next thing I want you to tell you about is this bit. So you need to remember, if I draw a unit circle with a biro that right, take that much down too, if you can make it out what it says. I bought a new jacket because I thought I'd be warm. I think I'm going to pass out, I'm so hot. Like wearing a duvet. I haven't taken it off since I got it. Oh, now I'm cold. The questions on these aren't really, they're not really hard. You just need to know about it. So take it with a pinch of salt for the moment. I know it's like I'm talking a foreign language at the moment, but when we see the questions, you'll see it's not that hard. And 0, 0. Three. We have 2 geometry chapters and the circle. Okay, so I'm going to go to geometry next, and I'm going to leave the circle until last because if it comes to it, you can leave out the circle question on the pre. Okay, but hopefully I might get them all done as well. What you do need, I'm finished. This is the last section in trigonometry, right? Okay, I'm not going to do a test on it if that's okay, because it's more important that I get the course finished, yeah? Okay, so this is the last section on trigonometry. We'll do a few with the test yourself questions. We'll leave it, we'll come back to it with the exam questions afterwards. Okay, we'll go into geometry then. Geometry is easy enough, the only thing is you need your math set. Okay, so will you, next week, will you bring in, next week bring in your math set, okay, is that right? And I'll do all the geometry, and I'll definitely have the 2 geometry chapters done, and I might get the circle, I might be able to sneak the circle in as well. The circle's only a week, if even. Right, is that okay? Right, so that's where we are, but I'll tell you which question to leave out if I don't get to the circle. Right, is that okay? Right, because I missed a week there before Christmas myself, so, right. Is that down? Unit circle, right, okay, so let's cut to the chase, right? The unit circle, right? Okay. If you have an angle in here, this is 0 degrees, yeah? This is 90 degrees, okay? Because remember, you have to go all the way back. That would be 90 degrees, right? This here would be 180 degrees, okay? So that means you have to go all the way back, right? This here would be 270 degrees. And this, I'm back around to 360 degrees. Is that okay? Right, full circle 360. So I go in anti-clockwise. So when I get to here, I'm gone 90 degrees. When I get to this line, keep going, I'm going this way. So the direction I'm going is anti-clockwise. When I get to here, I'm gone 180 degrees. When I keep going around, when I get to here, I'm on 270 degrees. And when I get back to the start.
Reception at the bell. Thank you.
Right, then you remember, do you watch Sex and the City? Sex, and you all know that show I'm talking about, don't you? Sex and the City, do you watch it? Right, Sex and the City, that's how I remember it. If you don't watch Sex and the City, remember CAST, okay? C-A-S-T, right, okay? Right, so what this means is A stands for all. So if you have an angle in the first quadrant, as in if you have an angle between 0 and 90 degrees, sine, cos and tan are all positive. The whole lot of them are positive, right? The S in this one stands for sine. So sine is the only one that's positive. So if you have an angle between 90 and 180, if you get the sine of it, it's going to be a positive number. If you get the cos of it, it's going to be negative. If you get the tan of it, it's going to be negative. The only one that's positive in here is sine, right? T stands for 10, and that means if you have an angle between 180 and 270, and for example 200, right? If you get the tan of 200, it'll be positive. If I get the sine of 200, it will be negative. If I get the cos of 200, it will be negative. The only one in here that's positive is 10. So any angle between 180 and 270, if you get the tan of it, it'll be positive. If you get the sine of it, it'll be negative. If you get the cos of it, it will also be negative. Right? Finally, C, the C stands for cos. So if you have an angle between 270 and 360, for example 300, right? If you get the cos of 300, it will be positive. If you get the sine of 300, it will be negative. If you get the tan of 300, it will be negative. Now I know you can do it on the calculator, right? And that's what you would do. But there's one case where you need to figure it out. We'll get to that in a while. For the moment, we're just trying to work out positive or negative. Right, if I said to you, using this, 0 to 90, 90 to 180, 180 to 270, 270 to 360. If I said cos of 70, would you say positive or negative? Cos of 70. Would you say positive or negative? 70 degrees is in here, isn't it? And everything is positive. So cos of 70, positive. Right, if I said cos of 100, right, where would 100 be? It's between 90 and 180, isn't it? So 100 is in here somewhere, isn't it? So if I said cos of 100, what would you say? Negative, because the only one that's positive is sine. In here, the only one that's positive is sine. If I said cos of 300, cos of 300, where would I find 300? Be over here, wouldn't it? Between 270 and 360. Cos of 300, positive or negative? Positive. Right. Sine of 250. Sine of 250. Where's the 250? It's in here, isn't it? Sine of 250? Negative. Right. Sine of 60. Positive. Tan of 100. Negative. Right. Tan of 300. Negative. Tan of 200. Positive. Right. Tan of 50. Positive. Okay, did you get what the unit circle tells you? So it doesn't tell you what the number is, it just tells you whether it's positive or negative. And I know what you're thinking, you could do it on the calculator, and yes you can, but there's one type of question that you need to know this stuff for, okay, which I will get to in a few minutes. Alright, is that okay? So what we're going to do is we're going to do a few of these, right, okay? Okay. Will you have a go at page 555? 1, 2. Just do 1 and 2 for the moment. Right, okay. And then 555, just do 1 and 2 for the moment, and then I'll come back and show you another bit. Remember the coordinates are cos sine theta sine theta.